We're going to have a brief look at how to identify integration techniques. So we've got 3 different integrals here. It's important to select the correct technique. So if we look at this first one, we can see that we have one function multiplied by another function. Generally that implies that you'll be using the product rule, especially if these functions are of completely different forms. So in this case we'll use the product rule. So we want to identify u, because we want to differentiate that. It will get simpler if we differentiate it, and this one will be our v dash. That one won't get too much worse if we integrate it. Okay, so we would identify u dash, 2x, v is minus cos x. Careful of your signs when doing a by parts with sine. You can get lots and lots of sign errors. Okay, so we're going to get x squared cos x, not forgetting your negative, and then minus the integral of u dash v, 2x. Rather than put a minus in here, probably more reliable to just change the sign there. This requires the by parts again, so I can just do this again. U v dash. You'll always keep u and v the same basic function. So if we were differentiating the x squared, we'll now still differentiate the x. If we were integrating the sine, we'll now be integrating the cos. The reason for that is if you switch them around, it just takes you back to your original function. Okay, so we'll just do a quick little note. U dash equals 2, v dash equals sine x, and then we use by parts again. Plus, so uv, and then minus the integral of 2 sine x. Finally, integrating that, we'll get minus x squared cos x plus 2x sine x. Integral of sine is minus cos, but we already have a minus there. Keep the sign simple. 2 cos x. Always remember your plus c. Okay, so in that case, usually if we've got 2 different types of functions multiplied together, we'll be using by parts. The next one, however, is the exception to that rule. At first glance, this appears to be by parts because we have 2 different kinds of functions multiplied together. However, the thing that we've got to check is, can we do this by inspection, sometimes known as a reverse chain rule? I know that if I were to differentiate something of the form e to the x squared, the derivative of that would be 2x e to the x squared. Notice that I'm multiplying by the derivative of this secondary function. That is the form I have here. So in this case, I can do this very quickly in my head just by inspection. I notice that because if I differentiate e to the x squared, I will get something of the form x e to the x squared. I know I can just reverse that process. So the integral will be e to the x squared. I should have had a 2 there because the derivative of x squared is 2x. So I'll just need to divide by that. Okay, divide by the 2, I get a half. Again, always remember your plus c. I can only do that because the derivative of v to the x is of the form x e to the x. Therefore, integration reverses that process and it will get rid of that x for me. That's the exception, if the chain rule could be the cause of that x there. We kind of have a similar scenario here. You may think that this should be done by substitution, and indeed you could do it by substitution. Let u equal the denominator. This will work, however there's a much easier way. Similar to here where we noticed that that coefficient was the derivative of this, again we see that the coefficient, if we think of it like that, of x cubed plus 2, or 1 over x cubed plus 2, the derivative of that is x squared. So we just need to think, well, what differentiates to give me 1 over a function? And we recognise that as ln. Quick check. The derivative of that should give me 3x squared. I've only got x squared. Therefore, I must require a third of this integral. Okay, you can check that if you differentiate ln x cubed plus 2, the derivative of that would be times by the derivative, 1 over the secondary function. I've got 3 lots of it, so I must want a third of that original function. Okay, that can be one of the main difficulties between spotting what's just a reverse chain and what requires the product by parts. You only require by parts if there is no chain from that inner function which would explain that coefficient there.